This video is talk about the convolution integral. Okay, first let's define convolution of two functions. If give you two functions ft and g of t, the result is another function of t defined this way: 0 to t f t minus tau g of tau d tau. If you do the variable change, you are going to find out this is equivalent to, say, give you f tau g of t minus tau. Okay, that's same thing. Okay, now let's look at an example. The convolution of two functions. Give you another function. Okay, let's get some idea about that. Okay, for example, ft here equal to t equal to cosine t. G of t here equal to 1. Okay. So the convolution of two f and g. See what we got. Okay. By definition, 0 to t f t minus tau. Okay. So it's a cosine, replace your t by t minus tau. Then times g of tau. G of t equal to 1. So it doesn't matter what is it. G of tau also equal to 1. So d tau. Okay. You integrate this one, you are going to find this one give you sine, give you negative sine t minus tau. Okay. Evaluate at 0 and t. Okay, once you integrate this, you let u equal to t minus tau, then du equal to negative d tau. That's how you get that negative sign. Okay. And this one is equal to, substitute tau by t, give you 0. Okay. Then subtract. Okay. So substitute tau by t, you got a sine t minus t. Then subtract negative. Substitute tau by 0. Okay. So sine 0 give you 0, so you got sine t. Okay. This example just show you if your ft equal to cosine t, your g of t is equal to 1. Convolution of those two functions give you third function of t, so like sine t. Okay. Okay, now the next we're going to find out the Laplace transform of a function. This function, you get this function by the convolution of f and g. Okay, by definition, this is Laplace transform of 0 to infinity, e to the negative st. Okay. Then the function we are looking for is inverse Laplace transform, is f convolute g, okay, which is 0 to t f t minus tau g of tau d tau. This whole sense, this is f convolute g. Okay, this whole sense then dt, which equal to 0 to infinity and 0 to t e to the negative st f t minus tau g of tau d tau dt. This is like a double integral. Okay. Now let's see what this is. Double integral, what's the region we integrate it. So we have t here, tau here. Okay. Now look at outside integral. T from 0 to infinity. Go to all the way there. So fix t between. Then your tau is bigger than 0 and less than t. Okay. So this line is tau equal to t. So tau is bigger, for given t, tau is bigger than 0, less than t. Okay. All right. So that's the region we integrated with. Now what we're going to do next, we're going to switch from d tau dt to dt d tau. Okay. So everything is same, like negative st f t minus tau g's of tau. Now we want dt first, then d tau. Okay. Now let's fill those four things. Okay. Now, so we go this way. Tau from 0 to infinity. Okay. Then you fix tau in between. Your t should be bigger than this one and less than infinity, right? So first of all, tau, this region, tau is go from 0 to infinity because they go all the way there. So tau is from 0 to infinity, and t is, this go with the t. T is bigger than this. So t is bigger than tau, less than infinity. Okay. So that's what we have. Okay. So now let's make variable change. Okay. Let u equal to t minus tau. So t here is equal to u plus tau, right? So you replace t here by u plus tau. Then if t minus tau is u, fu. Then g's of tau. dt equal to du, right? This is a dt equal to du. So this changes to du, then d tau. Okay, now let's look at this. T is from tau to infinity. When t equal to tau, u equal to 0. Okay. When t equal to infinity, then u is infinity. Okay. So we got this. And this one can be write 0 to infinity. 0 to infinity. E to the negative su, then e to the negative s tau. Then fu g's of tau, du d tau. Okay. And this one is equal to, okay, this is integral inside the du. And anything is independent of u, you can pull that out. Like we have e to the negative s tau, there's no u there. And the g's of tau. There's nothing to do with u, so you can put that out. Then you got e to the negative su, fu, du. Okay. Then d tau. Okay. This thing is independent of tau, so you can put that out. Okay. So you end up with 0 to infinity, e to the negative s tau, g's of tau, d tau. Then 0 to infinity, e to the negative su, fu, du. That's exactly give you, this is the definition of Laplace transform of small ft, which we call capital Fs. And this one give you Laplace transform of small g's of t, which we call, normally we use this. Remember, capital Fs is a Laplace transform of small ft. Okay. Doesn't matter here, use t there, or u there, the same thing. G's of s is a Laplace transform of small g's of t. Okay, same thing. Okay. So let's summarize what we just derived. The convolution of two function Laplace transform just equal to, it's equivalent to say find the Laplace transform of small f, then find the Laplace transform of small g, then multiply them together. Okay. And remember, if this not a convolution, just f times g, this is not equal to is not equal to Laplace transform of small f times the Laplace transform of small g. Okay. Let me write this again more clearly. Convolution of two functions together means you can find the Laplace transform of each one. Then multiply them together. That is what we call capital Fs, capital G sub s. So this means this. Inverse Laplace transform of capital Fs times capital G sub s. If you want to find the inverse Laplace transform of two functions multiplied together, what you need to do is find inverse of this one, then find the inverse of this one. Inverse of this one is small ft. Inverse of this one is small fg. The convolution of this will be the inverse of that. Okay. Now let's look at an example. How we apply this formula to find inverse Laplace transform. Okay, capital Hs is equal to a over s squared plus a squared. And we want to find, okay, what do we want to do? We want to find the inverse Laplace transform of Hs. And obviously Hs can be written as 1 over s squared times a over s squared plus a squared. If we call the first one capital Fs, the second one capital G sub s. So what do we need to do? So this is like this. We need to find inverse Laplace transform of capital Fs and the capital G sub s, right? With capital Fs here is 1 over s squared. Capital G sub s is a over s squared plus a squared. So by using this formula, what do we need to do? Find the inverse for this one, that one, then compute the convolution of those. Okay. Obviously, the inverse Laplace transform of capital Fs, which is 1 over s squared, is t. Okay. And the inverse Laplace transform of capital G sub s is sine at. Therefore, inverse Laplace transform of capital Hs is inverse Laplace transform of Fs over G sub s, which is equal to F convolute G. For our case, this is my F, this is my G. So 0 to t minus tau times sine G sub tau. Okay. So sine a tau d tau. So to find the inverse Laplace transform of this, what do you need to do? Find the inverse of each one, then you compute the convolution. What do you need to do? Just integrate this. Give you 0 to t. You just spread this, okay? Give you t sine a tau d tau minus 0 to t tau sine a tau, okay, d tau. Okay, the first one is easy to integrate because we integrate about the tau. T is a constant. T is treated as a constant. You can put that out. So you put that out, you just need to integrate this. Give you negative 1 over a cosine a tau. Evaluate 0 and t. Okay, the second one, you need to use the integration by parts. You're going to get like this, 1 over a t cosine at plus 1 over a squared sine at. Okay. You got the second part by this tau there, you cannot put this out. So you have to use the integration by parts to get this. Okay, when you simplify this, you got this at minus sine at divided by a squared. Okay. Okay. Now let's look at another example. This example, we're going to solve this differential equation. Y double prime plus 4y equal to g sub t. Okay, g sub t can be anything, any function of t. And y0 equal to 3, y prime 0 equal to 1. So we want to use Laplace transform to solve that. So you apply the Laplace transform on both sides of the equation. You got this. G sub t. Okay, Laplace transform of small g sub t. We give a name, we always use capital G sub s. Okay, when you use the formula, this one can be written s squared Laplace transform of y. Then minus s y0, then plus y prime 0, then plus Laplace transform of y equal to capital G sub s. Okay, we call this one is capital Ys, right? So we got s squared capital Ys minus s times y0. y0 equals 3, so 3s. Y prime 0 equal to 1. Okay, so plus 1. Then plus another capital Ys equal to G sub s. So we combine those two Ys. We got s squared. We have 4 here, sorry. I have 4 here. I missed 4. We have 4 here. 4 here. So plus 4. Then you got s squared, y capital Ys equal to 3s minus 1. Give you 3s minus 1 plus G sub s. So you solve the capital Ys, give you 3s minus 1 over s squared plus 4 plus capital G sub s, s squared plus 4. Okay. So small y of t equal to inverse Laplace transform of capital Ys, which is the inverse Laplace transform of each one. Use the property of inverse Laplace transform. G sub s, s squared plus 4. Okay, now let's find the inverse Laplace transform of each one. Let's find the first one. 3s minus 1, s squared plus 4. By using its property, give you inverse Laplace transform of s squared plus 4. You put the 3 out. Minus inverse Laplace transform. You got a 1 here. You got s squared plus 4. Okay, if you want to use a formula, you need 2 on the numerator. So you divide it by 2. You multiply 2, you divide by 2. And this one gives you, using formula, 3 cosine 2t. And the minus 1/2 sine 2t. Okay, this is use the formula. Okay. Now, then let's look at this one. Look at the second one. Okay. How to find the inverse Laplace transform of G sub s, s squared plus 4. This one can be written as inverse Laplace transform s squared plus 4 times g sub s, right? So in order to find the inverse Laplace transform, we need a 2 here. So we change it to this to 2, then we divide it. Okay. So we call this one capital Fs. Okay. So this can be written as inverse Laplace transform of capital Fs times capital G sub s. So what do we need to do? Okay, my capital Fs here is 2 over s squared plus 4. Okay, it's the inverse, small ft. It's the inverse of that, which is sine 2t. Okay. We call g sub t is the inverse Laplace transform of capital G sub s. Okay. Therefore, this one is equal to 1/2 f convolute g, right? So my f here, by definition, e to the 0 to t. Then ft minus tau. My ft, small ft equal to that. So you got a sine 2, replace t by t minus tau. Then g sub tau here, d tau. So we find inverse Laplace transform of the second one. Therefore, my small y sub t, which is our solution, is the inverse Laplace transform of capital Ys, is equal to 3 cosine 2t minus 1/2 sine 2t, then plus 1/2 0 to t sine 2t minus tau, then g sub tau d tau. Okay. Now, if you give me if they specify this one, you just plug in, integrate that, you find your solution.